good morning or evening or wherever it is for you. And we're going to be going through the study guide, and I have various items on the study guide that we're going to be looking at. And we're going to be looking at working our way through them. The ionic compounds, metal and a non-metal. This is two non-metals. And you can also have polyatomic ions here. So here you would have something like CO2, N2O4, C6H12O6, something like that. Up here we would have like KNO3, Na2SO4, KCl, KBr, things like that. Percentage yield problems. What's the percent yield of 18 grams of hydrogen react with excess oxygen to make 150 grams of water? So H2 plus O2 make 2H2O. In this case, we have this is the actual yield. And so actual divided by theoretical, which we get from Stoich, times 100 will be the percent yield. So we'll do our mass stoichiometry problem over here. We'll take 18 grams of H2. 1 mole is 2 grams per mole. The mole ratio between water and hydrogen, 2 waters for every 2 hydrogens. And then water is 18 grams per mole. That's going to cancel. 18 over 2 is 9. 9 times 18 is 162. So 150 over 162 times 100 is, I don't know. Let's see. About 92.6%. So there you go on that. On these next ones, I could ask it to you either way. I didn't give you an example of both ways, but obviously what I'm doing, you would do the opposite. So here, 34 grams of HCl, we want to change to moles. So we'll divide by the molar mass. If I gave you the moles, you would just multiply by the molar mass to get the answer. And 34 over 35.5 is about 0.958 moles. So that gives you those. Calculate the number of atoms when given moles or moles when given atoms. So if you had 6 moles of lead and you want to know atoms, you'll multiply by Avogadro's number. And that comes out to be 3.61 times 10 to the 24th atoms. The opposite of that would be if I gave you the number of atoms, you would divide by 6 times 10 to the 23rd, and then that would give you the number of moles. So that's how you'd work that thing. So if we move this thing up, let's see. Now we can do our molar volume problems. And in those cases, on our molar volume problems, we will, if you're given liters, which I am here, you divide by, make sure you bring your mole map to the exam. And very simply, if you want to go to moles from that, you would just do that, and you get 2.77 moles. Opposite of that, if I gave you the moles, you'd multiply by 22.4 liters. Now, on our percent composition problem, it's a little more detailed. That's going to require that we have K, Mn, and O. There's one of these, 4 of these. We will multiply them by their molar mass. I believe this one's 54.9, and that's 39.1. So this is 39.1, 54.9, and 64. Add those up, you get 158. Take each one divided by 158, take them times 100, and you'll get your percentage. And in the first case, we get 24.7%. This one's 34.7, and this one's 40.5%. So that gives you the percentage by mass of each element in the compound. So each one multiplied by their molar mass, by how many there are, and then that total divided by the total of all the masses will be the percentage that each one is by mass in those compounds. Next up, we have empirical formula, and that's the smallest whole number ratio of elements in a compound. And in this case, anything that's a 1-to-1 ratio is automatically an empirical formula. This is 2 times this formula. Excuse me. So we could divide this by 2 and get this, so that's not an empirical formula. Here we have a 1. Anytime we have a 1, so there's a 2-to-1 ratio there. And you got to be careful here because these H's can be combined. So we take 3 and 1 is 4 H's, C2O2, and that could be divided by 2, where it would be H2CO. So in this case, you can see that this is not an empirical formula again. Now, if we're given the percentage data, we can get the empirical formula from that percentage data. And the way we go about doing that is we simply take the information that we're given. It'll usually be given in percent materials. If it's not given in percents, it may be given in grams, but usually it's given in percents. So we'll take each one of these. We're going to assume we have 100 grams. We're going to get rid of the percent sign. And we're going to say we have 72.6 grams of chlorine. And we're going to have 24.3 grams of carbon. And we're going to have 4.1 grams of hydrogen. And we're going to take each one and divide by their molar mass. Don't make a mistake here. Don't divide by the smallest. That's coming up later. So I'm going to do that to each one. And don't use the diatomic masses here because we're trying to find out what the formula is. We don't know if it's going to be a 2 or not. So that looks like that's 4.1 moles. This looks like that's 2.05 moles. And this on the calculator, I think, comes out 2.05 moles as well. Now we'll divide them all by the smallest, which is 2.05. And here I get 1, 1, and 2. So this would be CH2Cl. And that's the empirical formula there. Remember, if these don't come out to a whole number, like if this came out 1.5, you would multiply this by 2, and then you get a 3, but you'd have to do that to all of them. But this one did not do that. I just giving you an example of that and showing you what was going on with that one. So that's how you do the empirical formula problems. The next type up are typically the net ionic equation problems. And in these, you have a reaction between 2 compounds, like silver nitrate and calcium chloride. So in this case, what we'll do is we have to think about solubility. We have to think about a lot of things. And I'm going to get back with you on the next video on number 10 here. So this video is going to stop, and I'll get back with you with it.